Yes, class. Aisha, Maha, audible to you, both of you?
Yes.
So, good evening. In the last class, we had started with uniformly accelerated motion, where if your acceleration is constant, means the value of acceleration is not changing. Then you can use three equations. You are permitted to use three equations. Those three equations basically include V is equal to U plus AT. Second equation says S is equal to UT plus half AT square. Last equation says V square minus U square is equal to 2AS. So we had discussed that equation. We had done very easy question also, and we had done a standard question as well, where we had calculated the total time, acceleration, retardation. Any doubts from the last class? Ask me. You can text me also even. Right now you can text me the doubt. Now, one equation I told you that we'll discuss later, remember this one, Sn equals to u plus a by 2 into 2n minus 1. So this equation was left. Let's complete this equation as well. How to apply this equation, how to use this equation, how can questions come in this equation. So this is basically the equation for displacement and covered in nth second. So we'll discuss what is meant by nth second. So this is displacement covered in nth second. Now, see, let's say a body has started from point A. Initially, it was at rest, or initially, it was also having some velocity, let it be. It starts from point A. All right. Now, at point B, let's say this time taken is 2 seconds. So, from A to B, the body has traveled and the time interval is 2 seconds. Then it reached the point C, and the time duration that covered in this is, let's say, this is 1, this is 2, this is 1 second. Then it reached this point D. Again, it moved forward, and the time duration in this was, again, let's say it was 2 seconds back, this duration. Then it reached one more point. Let's say the time that took here, T4 is 4 seconds, and it reached this final point. Let's say F of T5, F it has reached. So T5 is, let's take any second random, let's say 5 seconds. These are all the time intervals given, all the duration from A to B, 2 seconds, B to C, 1 second, C to D, 2 seconds, D to E, 4 seconds, D to E to F, 5 seconds. All right. Now see, if I see this from A to B, this is the first time interval, first one. Whatever be the value, be it 2 seconds or whatever, like in this question, it has mentioned 2 seconds. So just take it as first interval. From B to C, this becomes what this becomes your second time, the second one. From C to D, this duration becomes third one. D to E, this becomes your fourth duration, from D to E. And E to F, this becomes your fifth second. Fine, all these. Now, when we are given time duration or time interval or any time value that we were using in the previous equations, there we had used what? We had all these values that were mentioned. These values we had. Nth second means, for example, I ask you calculate the displacement covered in the third second. This is what is meant by nth second. These intervals are your nth. Let's say supposedly there must be some point, and this is the time interval, we don't know, let's say nth. So this is basically what we say displacement covered in nth second. Means only in this interval from C to D, that is known as nth second. So for that we have a special equation which I have already told you. When we use those equations, the earlier three equations, V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS, all these three equations, then these times are mentioned to you. For especially for nth second, you have these time intervals. For example, if I say n is equal to 5, That means fifth second. So it means I want the fifth second, and it becomes the displacement covered from E to F. This just this displacement. So when I'm talking about, let's say, third second, so third second becomes displacement covered from C to D. Similarly, if I'm saying, for example, if I'm saying fifth second, then this becomes the displacement covered from E to F point. Fifth second this happened. So this is covered from E to F. Now all these intervals will be uniform. Why? Because uniform acceleration has been considered. So uniform velocity will be there, or it can happen uniform time instant can be there. You can use this equation only if your acceleration is uniform. Non-uniform acceleration means acceleration is variable, like 5t square, something like this, any other value. So this is what we call nth second. Understood the meaning of the term nth second? First tell me this.
Yes.
Clear? All right. Now see one more thing in this. Now this you have understood what is the meaning of nth second when we refer it to what is the displacement covered in nth second. Right now see, we have to find the interval, the displacement from E to F. So let's say the total displacement that is covered from A to E point. This is, let's say, this is SE, displacement covered from A to E point, this whole. All right. And let's say the total displacement that is covered from A to F point, this is SF. Now can any one of you tell me what should be the displacement between E and F? Total displacement from A to F is SF. Displacement from A to E is SE. So what should be this distance, this much distance? Yes, exactly. That is SF. So the net displacement that we are calculating in the nth second, that is actually SF minus SE. Means whatever is the time covered. So this is the displacement that we are actually trying to find. SF minus SE. If I am referring to fifth second, that's how we calculate it. So now see, if I am taking nth second, let's say some random second, let's say the fifth second. So displacement covered till the fourth second mean the t is equal to 4 minus the displacement covered in t is equal to 5 seconds. This displacement we are calculating. So basically our nth second is what? Nth second is n minus 1 to n seconds. Let's say fifth second is what? N minus 1 means from this fourth second to fifth second. So n minus 1 to nth second. That's what we are calculating. So now you can simply use your equation, the equation that we use in this case. We get such a case where you have to calculate for a specific nth second, fifth second, sixth second. 5 seconds are different. See, had it been t is equal to 5 seconds, t is equal to 5 seconds means these. This. If it says fifth second, so that becomes the slot of fifth, whatever can be the displacement from there. So t is equal to 5 second differs from t is equal to fifth second. This is different. I hope you people are able to understand the difference between them. If not, ask me. If you get this case, so displacement will be what? For nth second, displacement is basically u plus a by 2 divided by 2n minus 1. Now u is the initial velocity, a is the acceleration, 2 is the constant, n is the value of the nth second. And what is s nth? It means displacement covered in nth second. So let's do a question on this. Before that, you note down these things. We'll see how to use this equation. Otherwise, if nothing nth term like this is not mentioned, simply all the equations that we have studied in the last class. Now see, the question says the body starts from rest and accelerates at 2 meter per second square. First and second parts are very easy. People will be able to read it. You try. Acceleration is given 2 meter per second square. Initial velocity will be 0 because it starts from rest. You have to calculate the displacement covered in 2 seconds. So in the first part, the time has been mentioned you 2 seconds. Which equation should we use, Maha?
Ma'am, S is equal to UT plus half AT square.
Yes, S is equal to UT plus half AT square. So UT, this will definitely be 0 because U is 0. So S will be equal to half. Acceleration is 2. T square becomes 2 into 2. So that becomes 4 meters. So S is 4 meters. Aisha, which equation should we use in the second part? Yes, Aisha, for T is equal to 3 seconds. Same equation. Same equation should be used for it. So this becomes again UT plus half AT square. So this term will be 0. This will be equal to half A and T square. So that becomes 9. So S is equal to 9 meter. Now see, this is what? This is S2, this is S3. Now see, the last part is asking us nth second. Definitely third second is your n is equal to 3. Now you can calculate the answer in two ways. What is meant by third second? Third second basically means if this is your S3 and this is your S2, then this is what the question is asking. This is your third second. That's what we did. No, SF minus SE we wrote. So this can be directly, you can do it this question in two ways. First method says you can directly subtract S3 minus S2. That becomes 9 minus 4, which gives 5 meter. So this S third will be 5 meters. One method is this, directly subtract S3 minus S2. But in this question, you will be able to subtract because you have already calculated the value of S2 and S3. And in this question, the values are so easy that you will be able to subtract it. But what if values are very large and the nth time is so much high and you don't have the information for calculation of the previous second that you are not aware of? So we can use the nth equation that we have studied. So S3, S third will be equal to U plus A by 2 to N minus 1. Initial velocity is 0, acceleration is 2 by 2, 2 into. Can anyone tell what should I write the value of N here? 3. That will be 3. So 2 into 3 minus 1. So you can see this becomes 6 minus 1, that is 5 meters. So by both the ways, you're getting 5 meters. Let's do one last question that comes. This topic is, I hope, over. I hope you have understood this topic. Or let's do one more question from this topic that comes. Either this can come, very simple, straightforward equations. The other question that comes in your, even after your class 12, no, in your entrances, this question comes a lot. And in your class 11th also it can come. It can come. It's a part of it. Let me give you the question. Before that, you just note down all these points. Then we'll do that question. Yes, answers. Initial velocity and acceleration. Aisha, what's the answer you're getting? Maha?
No, ma'am, I didn't get the answer.
See, for 12 meter displacement for the second is given to you as 12 meter. N here is 2. Similarly, displacement for the fourth second is given to you as 20 meters. And the n's value is given here. Let's say this is S2, N2, and this is N4, which is given as 4. So two equations will be there. Two variables are there. You don't know initial velocity, you have to find out it. You don't know acceleration, you have to find out it. So S, what was the equation? Sn is equal to u plus a by 2. 2n minus 1 is the equation. Let's put the value for the first one. 12 will be equal to u we don't know, plus a also we don't know, 2. 2 into n. N is 2 minus 1. This is the first equation. Second equation. 20 is equal to u plus a by 2. 2 into nth here is 4 right now, no? 4 minus 1. Two equations are there, two variables are there. You just have to solve these two equations. See, in this, you can directly write this as 12 is equal to u plus a by 2, 4 minus 1. So that becomes 5, 5a by 2. And this becomes what? 20 is equal to u plus a by 2 is there. 8 minus 1 is 7. So equation 1 is there, equation 2 is there. You just have to solve these equations. Multiply everything by 2 so that this denominator thing gets eliminated. Or you can directly also subtract it. In any way you can. If you do it directly also, then see we have two equations. So this becomes 24 is equal to 2u plus 10a. Just multiplying the equations by 2. I just wanted to get rid of the fraction. Second equation is 20 is equal to 2u plus 14a. These are the equations that we are getting, right? 2, not 14 is 7 is. This will be 7a. And this will be 5. Because we are multiplying it with 2. 2 is in the denominator, no? So this becomes 5a. You multiply everything and this becomes 7a. So what we can do? We can subtract it. So if you subtract it, this term gets cancelled. Here 24 minus 4 is left 4. And here what do we have? Here we have 5a minus 7, that is 2. So here your acceleration becomes what? Here, one more thing. This won't be 20, no. This will also be 40. See, we have doubled the equation. So this will also be 40. Just this will also be 40. Now you can write. So 40 minus 24 becomes what? That becomes minus 24. And here you have this minus 2, you got cancelled. So this becomes minus 2a. This much is left, right? Fine, clear? Now what do we have to calculate? We have to calculate the value of u and we have to find out the value of a. This much we have to find out. Now, one more thing. So minus sign gets cancelled. Acceleration becomes 12 meters per second. Is this correct? Just see the calculations once again. These two equations were there, no? So that becomes 24. This becomes 2u. That becomes 5a. Fine. Or you can even reverse the equation if you wish to avoid the signs. Like you can write it in this way. 7a plus 2u is equal to 40. And you can write 5a plus 2u is equal to 24. Like this also you can. So here when you will put the negative signs, see, this term will get cancelled. This becomes 2a directly. And this, okay, this will become 6. And that becomes, okay, the answer will be 2 into 16. That becomes 4 meters. Just a second, this will be 16. So answer will be 4 meter per second. So acceleration from here also it will be 4 meter per second. So you can even reverse these equations or you can put it in. Now you have the, yes.
It's 8 meter per second.
It's 8. No, here it's, yes, it's 8 meters. This is 8. No, that's right. 16. Here, what did we get? Here we got 16, no? Over here. This will be 6. We got 16 over here. So it becomes 8 meter per second. This you were saying, no, Aisha? This is 8.
Yes, ma'am. Yes.
Now, yes, right. Thanks for correcting. So now you have the value of acceleration. You can put it in any of the equations. You get the value of u. So in this way, equations can come. Either it can happen, u's value can be given, acceleration's value can be provided, any value can be provided to you. So these kinds of questions also come. Now, one question is there that is not only based on this, that's a general question from your uniformly accelerated motion, but it deals with variable. Like up till now, we have calculated what? We have used numericals to find out the answer. Like here, the value was given 2, 5, 20, 24. All these values were provided. Fine. So similarly, what you have to do, if variables are given like alpha, beta, gamma, then how to get the answer? Because with the help of calculations, you will be able to do. But without the help of or without the aid of the numerical values, you should be able to write the answers in terms of numericals. So before we begin with motion under gravity, one more question we'll do. So as to wrap up this uniformly accelerated motion, this much you have written, this you have to write down. One last question we will do. One more thing, class. Just see. There's one more error. See here, that's why the answers were coming different. This won't be 5. This is 2 minus 2 into 2, that is 4 minus 1. So here it becomes 3. So this value will be 3 over here. See, 2 into 2 is 4, 4 minus 1. Like this was 2 into 4. So this was 8 minus 1. So here you have the value 3. So here also we'll be writing it as 3. So you get this term. So see, your answer won't be 6. This will be 4 now. This will be 4. So final answer will be what? 16 divided by 4. That's 4. This was 3, 3 here. So this becomes 4. 4 here, that becomes this. Also find out the value of u as well. See, if you put the value of u in any of the equations, put it any in of the equations. Let's say 7 into 4. plus 2u is equal to 40. Let's put it in this question. So 7 into 4 is 28. So you subtract it, that becomes 12. So 2u is equal to 12. U will be 6 meter per second. Let's discuss this question. So I hope you have written it and have once read it. Otherwise, I'll give you time to write it. It says a body starts from rest and accelerates at a rate alpha. Let's at least draw this one. Let's say A point is there. So body has started from rest. So it means initial velocity will be 0. It says and accelerates at constant rate alpha. So let's say till some B point, the acceleration here is alpha to a maximum velocity. Let's say this is some velocity that it has achieved. Then it retards at a constant rate beta. So retardation. What was retardation?
Negative acceleration.
Negative acceleration. So here A2 will be minus beta. And then it comes to rest, means this will be this final velocity, this is 0. All right. If the total time elapsed is t, so t is the total time elapsed, means throughout the journey. You have to find the maximum velocity. So can you tell me which variable out of all these you have to find out?
V.
V. Yes, exactly, because V was the maximum velocity. Remember here it said maximum velocity. So this was the maximum velocity you have to find. So let's just divide it into two parts. Let's say A to B and B to C. Let's divide it into two parts. Let's say the time is T1 here. Let's say time T2 is here. Fine. V is there, alpha is there. Alpha means your acceleration is there, time is there, and 0 is there. So from A to B, if you have to write and find the value and connect it with velocity, you will use this equation. This is from A to B. V is equal to U plus AT. See, final velocity for A to B, this is V. Initial is 0. Acceleration is alpha. Time is T1. For A to B at least. So from here, T1 is what? T1 will be equal to V divided by alpha. This is a very common. It's a very, very common. I think it once came in your NEET examinations. And from then, after 2 years, CBSE started copying that question. So it comes in the board exam, in the CBSE class exams also, 11th exams. Now B to C part we have to deal with. So A to B part is over, B to C part. B to C part. So if you use this equation, V is equal to U plus AT. Aisha, tell me what will be V here? Final velocity.
0.
C. It will be 0 because final velocity for B to C part, the car is stopping, so it means the car has gone into rest, the state of rest, that is no velocity will occur. V prime, basically we are talking about V prime, and V prime is 0, so velocity here this will be 0. Maha, can you tell what will be U for B to C? V, capital V. This will be V. Acceleration is minus beta, T is T2. Let's put it. So this becomes 0 is equal to V minus beta T2. And from here we can have the value of T2 as again, this becomes V divided by beta. We know one variable, that is the total time that has elapsed. So total time is what? Total time is actually T1 plus T2. V variable we have to find out. Alpha and beta are given in the question. T is also given in the question. T1 and T2 are not provided in the question. It means we have to eliminate them. So let's put the value of T that we have calculated using all those equations. So T becomes what? V by alpha plus V divided by beta. Now from here, let's take the LCM to solve it. So, or let's take V as common. So this becomes T is equal to V 1 by alpha plus 1 by beta. Take the LCM. T is equal to V beta plus alpha divided by alpha beta. Now, which was the variable that we were finding? As Maha answered, maximum velocity. So that was this capital V. So capital will be, V will be what? Alpha beta T divided by alpha plus beta. In this way, variables also can come. So note down this question as well as the solution, then we'll do the topic motion under gravity. Done?
Yes, ma'am.
Now see, those were related to straight line. When the motion was straight line, means gravity didn't play any role. Now you have a separate chapter on gravitational force, gravity, acceleration due to gravity, variation of gravity with height, even with rotation of earth. All these things are included in your gravitational. Right now we are going very, very slowly. So I hope you're able to understand these things. But in this gravity, I'll do this gravity portion in brief right now, because this is of no use right now. You just have to understand the term, the functional and the aspects of gravity and how it affects everything. That will all be included in that lesson. There you have everything. There you have the whole gravitational force formula for calculation of acceleration due to gravity and everything. Motion under gravity means if anything is falling and gravity is aiding it, be it upwards, downwards, in any manner, body is moving. Body can move upwards also. It can be towards gravity, against gravity, not in gravity eliminated plane. This is the gravity eliminated plane, not in this place. Either against gravity or towards gravity. Now, see, acceleration due to gravity. What is meant by acceleration due to gravity? Normal acceleration, you know. So there's a formula that you will be studying in the coming chapters, capital G into mass of Earth divided by radius of Earth. Or if you change the mass for a planet and put the radius for a planet, you will get the acceleration due to gravity for that particular planet. So, and capital G is a gravitational constant. It's a universal constant. In earlier classes, you might have studied it in your 9th standard. I think it is included as gravitational lesson. So you must be having an idea. Even if you're not having any idea, don't worry. We'll have to study all this in detail. That's a very short lesson though. Gravitation is not a very large lesson like this. Basically, we have to deal these lessons slowly, at least this lesson and the next lesson. Then we can move fast. So this is basically this formula. If we put the value of mass of Earth and radius of Earth, we get the value of acceleration as 9.8 meter per second square. This is mass of Earth. This is radius of Earth. This acceleration, which is due to the gravitational force, there is a difference between gravity and gravitational force. Details you will be studying later on. Right now, you just have to understand that the value of that gravitational acceleration. What's the acceleration that is coming because of gravitational force? That value, this is denoted by small g, that is 9.8 meter per second square. Now, in some questions, it can give you that take g as 10 meter per second square. But if this condition is not mentioned to you, that do not take g as anything or nothing is mentioned regarding g, and you know the body is is exhibiting the motion under gravity, or it's a free fall case or anything, and you have to use the value of g, then you won't use the value of g as 10 so as to ease your answer. Whatever answer you're getting in decimals, fractions, you have to calculate it. If many a times it happens that putting the value of acceleration instead of 9.8 makes your, instead of 9.8, if you write 10, then you get the answer. The calculations are easier. So the question will tell you take g as 10 meter per second square. So things will be mentioned in the question. Now in this formula, you can see it's a constant 9.8 meter per second square. This acceleration due to, this was the formula of actually acceleration due to gravity. accelerations. Even if you're not able to understand certain terms, why mass has been written, what is the value of capital G, what is R, why are we writing it, what are the other properties, so don't worry about it. You have full lesson in your NCERT book 1. So this is acceleration due to gravity. Gravity, you all people know in layman terms, the force that pulls us. So acceleration because of that pull is known as acceleration due to gravity. And from this, you can see this is just a constant value, 9.8 meter per second square. So from this, you can easily conclude the fact that it is independent of, this shows that it is independent of mass of the body, because it's a fixed composite value, 9.8 meter per second square. We round off it, that's a different thing, but it is not depending on anything. No, you're getting the constant value, so not even the mass, shape or size, anything. For example, if a person is falling down, the acceleration due to gravity that will act on the person, let's say the mass of the person is 70 kg. So if a 70 kg man is falling off, then the acceleration due to gravity will be 9.8 meter per second. If this pen, which I think weighs 500 grams, if this is falling, then also the value of acceleration due to gravity will be 9.8 meter per second. So this one thing that you have to remember, which is of use for this lesson. For this lesson and the upcoming lessons till you reach your gravitation, because acceleration due to gravity will be used till your laws of motion. Even in your work energy part, everywhere this will be used. Wherever anything is falling downwards or you're able to see this motion in this axis, y-axis, gravity acts. One more important thing, this was a very important point. Second important point says that acceleration due to gravity, this is always downwards. Obviously, why are we all standing on earth? Reason is that because a force is pulling all of us. Whatever be the value of that force, how to calculate that force, that is none of your concern right now. But everyone is able to stand, everything, if this is kept over here. Friction plays a different role, that we'll see later on, how forces like friction and other forces, normal reaction and everything play, or why things stop. That's a different thing to overcome inertia. But everything is ultimately in this y-axis. It's not moving upwards or downward, it is in static position because gravitational force and gravity. So gravity always acts downwards. Acceleration due to gravity, even if the body is moving upwards. Let's say I have thrown a ball. Even if you throw something like this, if you throw it like this, if I've thrown it. So what happened when I threw this? See, it went upwards at a point. When I threw this pen, it went upwards and then it went down. So what happened? Didn't gravity work at that time when it was moving upward, when I was throwing this upwards, and also gravity was acting? But gravity always acted downward. So what happened? Initially, it had so much momentum and it had so much velocity that it overcame the force of gravity. As the velocity decreased and it became zero, then it got back. Gravitational force dominated. Those things we'll study later on. Right now, you have to understand that it acts downwards. This direction is also very important. That this acts downwards. Now, when we'll do the questions of this, acceleration due to gravity will be required, you have to have a sign convention. Because it can happen, velocity is moving downwards, velocity is going upwards. For example, if I throw this pen, if I have thrown this pen with this velocity, let's say some 2 meter per second velocity, I have thrown this pen like this. So it is going upwards, velocity is going upwards. What will be the direction of acceleration due to gravity? That's fixed, means it will always be downwards. So if it is acceleration due to gravity is going downwards, velocity is going upwards. So there has to be a sign convention to differentiate between the different directions. So what do? You either take anything as positive or anything as negative. For example, let's take upwards motion as positive. I have taken upwards motion as positive. and downwards motion as negative. It's up to me. In whichever question I can take. In your subjective papers, you have to mention the sign convention is. If you don't mention the sign convention, then you will lose all your marks. Because, for example, Aisha is getting minus 4 meter per second square. And according to her, minus is upwards. She's getting minus 4 meter per second square. According to Maha had took, or when she was doing the calculations, she had taken downwards as negative. So her answer is also right. Both of you have the same answers. But if you don't mention the sign convention, both of you are getting 4 meter per second square. Aisha is getting minus 4 meter per second square. Maha is getting 4 meter per second square. But for Aisha, minus was upwards. For Maha, upwards was negative. Upwards was positive. So that's why Maha got plus 4 meter per second square. So if you don't mention what's your sign convention here in your answers, then you'll lose all your marks. You'll just get the marks for the magnitude. We have studied in earlier classes also. You all are aware of that vector quantities exist, scalar quantities exist, velocity, acceleration, displacement, all these are what? Vector quantities. So magnitude you will be giving correct. Both of you are having the magnitude as 4. But since the direction, if it is not mentioned correctly, your answer becomes incomplete. So this is the sign convention you can take, or you can take any other sign convention. You can take upwards as negative, downwards as positive, anything. For example, let me tell you what is the sign convention with the help of an example. Let's say a ball is thrown upwards. This is an example I'm taking. A ball is thrown upwards. Now the velocity with which this ball is moving upwards, let's say this initial velocity is 3 meter per second. Fine. Aisha, what will be the direction of acceleration due to gravity? Aisha.
Positive.
Yes?
Positive.
Upwards or downwards?
Upwards.
That's what I was telling you, no? See, acceleration due to gravity always acts downwards. Whatever is the motion, whether the body is moving downwards, whether the body is moving upwards, whether the body is moving forwards, or whether the body is moving backwards, the acceleration due to gravity always acts downwards. That's why you people are able to stand on Earth. Earth is a sphere. The person who is at this end is also able to stand like this. The person who is at this end is also able to stand like this. At this end, person is also able to stand like this because gravity is pulling it towards itself. So what's the direction of gravity now, Aisha?
Negative.
Direction, towards, upwards, downwards. It will be downwards. So acceleration due to gravity will always act downwards. Remember this. Now, negative, positive is up to you. Why are you answering acceleration due to gravity is negative or positive? See, negative and positive is up to you. For example, let you just choose anything, Aisha. Choose upwards as anything, negative, positive, whatever you wish. Just choose anything. Aisha. Positive. Okay. So Aisha says upwards. According to Aisha has chosen upwards as positive. So by convention and by default, downwards become negative. So for Aisha, when you will be answering, you will be writing which quantity is going upwards. This ball is going upwards with velocity 3 meter per second square. So this will be 3 meter per second square. And you will write acceleration due to gravity as minus 9.8 meter per second square. Now, if a person has this much data, the person will be able to conclude that upwards, okay, this child has taken upwards as positive. It means velocity is moving upwards. That is, the ball is going upwards. With this data, you will be able to conclude this fact. Let's say another ball is there that is moving downwards with velocity 5 meter per second square. So Aisha has chosen what? Aisha has chosen upwards as positive. So this ball is going downwards. So let's say this is U dash. So U dash will be minus 5 meter per second square. All these data will tell you G and U, these are acting downwards and this is acting upwards. Let's say Maha has taken upwards as negative in her answer. In her calculation that Maha did, Maha has taken upwards as negative. So obviously downwards becomes positive. So according to Maha will write initial velocity u as -3 meter per second square. And Maha will write u prime and g both as +5 meter per second and 9.8 meter per second square. This won't be square. This is just. These are velocities. All right. So with this shows what? This shows obviously velocity is moving downwards and ball is moving upwards. So see, by any sign convention, are we reaching the same conclusion? Here also, this was the conclusion. Here also, the conclusion is same. Did you get it? Sign convention is up to you. Take any sign convention that you want to take. Do one thing, note down these things. If you get stuck, you're not able to understand, let me know. Otherwise, it will be very confusing. First, note down these points. And ask me if you have doubts. Motion under gravity, then otherwise it will become very difficult. Because equations will remain the same. All the equations you studied right now, that will only repeat with just the sign convention. Just text me done when you have completed.